Hey everybody, today's lesson from Unit 2.2 deals with some proportionality theorems. So far we've used proportions in similar triangles, and today we're going to take a look at a triangle proportionality theorem and also how we can use proportions with parallel lines. So in our first example, called the triangle proportionality theorem, it states if a line parallel to one side of a triangle intersects the other two sides, then it divides the other two sides proportionally. So what this means is, in the case of this figure, you see that line segment AC is marked parallel to DE, and those two segments intersect the two sides of the big triangle, triangle ABC. Then, according to our theorem, those two sides are divided proportionally. So BD, this little line segment right here, would compare to AD, this portion right here, in the same way that EB, or BE, compares to EC, or CE, on the other side of the triangle. So those two segments are in the same proportion as the two segments on the other side. Now, another proportion that we can get from this is to say that line segment BD corresponds to line segment BA in the same way that BE corresponds to BC. And we can say that because the little triangle is similar to the big triangle because of the angle-angle theorem. We can also say, in a slightly different way, that line segment DA, that little piece in this triangle, over BA, the whole side of the triangle, would be equal to CE, this little piece, or we can call it EC, over this whole side. And we're going to call that BC. So you can compare this piece to this little piece, follow the same pattern on this side of the triangle. You can compare this side to the whole entire side, and again do the same thing on this side of the triangle. Or you can even compare this little piece to the whole side, and this little piece compared to that whole side. So the converse of the triangle proportionality theorem says, if a line divides two sides of a triangle proportionally, then it is parallel to the third side. So we'd use this to prove whether or not AC and DE are parallel. So if, and I know they're marked parallel in the picture, but we're trying to prove that they're parallel. If we can prove that BD over DA is equal to BE over CE, then line segment DE, let's clean that up, line segment DE will be parallel to line segment AC. So let's check this out. In our picture, BD is equal to 8, so we're going to have 8 over DA, which is 4. We're going to see if that's equal to BE, which is 12, over CE, which is 6. So if you check it out and simplify your fractions, we get 2 over 1 is equal to 2 over 1. So the answer is yes, that DE is definitely parallel to line segment AC. Okay, our final theorem for today says if 3 or more parallel lines intersect two transversals, then they divide the transversals proportionally. So if line N is parallel to line J is parallel to line M, then line segment AB corresponds to line segment BC, in the same way that line segment DE corresponds to the length of line segment EF. So this allows us to, set up proportions comparing those segments and solve for missing lengths in a diagram. Okay, so it's time to put those three theorems into practice. In our first example, we want to find the length of line segment AB. And I'm going to choose just to label it with X just to keep it a little bit simple. Notice in here that these two segments are parallel to each other. So according to our triangle proportionality theorem, our two sides are divided proportionally. So we can set up a proportion like this. We can put the length of AB, which is represented by X, over 3, and set it equal to 12 over 4. Now, you could go ahead and cross multiply if you wanted to. You can get 4x is equal to 36. Just take 4 times x, takes 3 times 12, and then take and divide by 4. You get x equals 9. You could also simplify your fraction first. So we have x over 3 is equal to 3 over 1, because you can simplify 12 over 4 to 3 over 1. Cross multiply, we get x equals 9. So any way you look at it, the value of AB, the length of AB, is equal to 9. In our second example, we want to determine if line segment SY is parallel to line segment EL. So we want to figure out if these two line segments are parallel. So if we can prove that these corresponding segments are proportional, then we can conclude that those two lines are parallel, according to the converse of the triangle proportionality theorem. Again, this theorem says if a line divides two sides of a triangle proportionally, then it is parallel to the third side. So let's compare our sides. We have 18 over 10, and see if it's equal to 24 over 15. So simplify both of the fractions. In the first case, divide by 2, we get 9 over 5. In the second case, 24 over 15, the common factor would be 3. Dividing by 3 leaves us with 8 over 5. Obviously, they're not equal to each other, so the answer is no. Line segment SY is not parallel to line segment EL. Okay, in our final example, it says, for the figure below, which statement is not true? Okay, so we have parallel lines as evidenced by our symbols right here. And we're using the final theorem that we covered, which says if 3 or more parallel lines intersect two transversals, then they divide the transversals proportionally. So we have to find which of these proportions is not true. So we're looking for patterns here. So in the first case, this one, check it out. It says that KL over LM would be equal to PO over ON, and that's true. So that's not our final answer. I'm going to clean this up a little bit, and we'll take a look at the next proportion. Okay, so next we have line segment ON over line segment PO is equal to line segment LM over line segment KL. That's true. All right. So I haven't found our solution yet. In the third case, it says the line segment LM divided by line segment MN is equal to line segment ON divided by line segment MN. This is false. Okay, so our theorem says that only these segments are divided proportionally. It doesn't tell us that these segments compare to any of these segments in the center of the figure. Alright, just to be clear, let's take a look at the last proportion and check out whether or not it's true or false. So in the last case, it says that line segment KL corresponds to line segment KM in the same way that PO corresponds to Pn. And this one would be true as well. Okay, good luck on the CYU. As always, make sure you speak up if you have questions.